because it kind of takes a little bit. There's 2 or 3 different ways you can do it. Here's the problem. So go ahead and write it down. It is a good test question. And I went ahead and did all the, let's see if I can bring it in. I don't know if it's saved. Let's see if it's saved, how to do it. Paste, I bet I won't be able to bring it in. Let me hit Control V. Control V. Nope, it didn't save it. So I'm going to have to go through. All right. So this is a test question or a homework question. It says you are given a choice of investing $3,000. Okay, that's not the right question because I've already typed it in. Hold on. I done regenerated a question because I answered it. So let me pull the question back up in its original form. There it is. Number 20, on line number 20. There it is. Okay, so here's the question. At $2,000, you putting $2,000 in a savings account at 6% interest. And you want to choose between annually or monthly. So what do you need to do? Plug everything in, monthly and annually. So you're going to have two choices. Here they are. A is equal to P times 1 plus R over N raised to the NT power. And I'm going to go over here and this is A sub 1, this is A sub 2. P 1 plus R over N raised to the NT power. Now this says P is equal to 2,000 and R is equal to 0.06. N is equal to 1 and N is equal to what? 12. Now plug and chug. So I'm going to start you off. Equals 2,000. 1 plus 0.06 divided by 1 to the 1t power. A sub 2 is equal to 2,000. 1 plus 0.06 over 12 raised to the 12t power. Now all you need to do is condense what's inside the parentheses. So that's going to be 2,000. And I can do this in my head. 1.06 to the what power? To the t power. And that's your y sub 1. And of course change this to an x in your calculator. And now a sub 2, which is going to be your y sub 2, is equal to 2,000. 1.005, I think. Somebody check me. The 12x. And that's your second choice.
Yeah, it is.
Okay? Now, the reason I'm going to make this a calculator question, the reason I'm making this a test question is this is really a calculator question. That's all the algebra you need to do. You're done with the algebra. That's it. This is all the algebra you need. Now it's what? Graph it on what? Now I've already done it for you. And I've also done it on the Excel spreadsheet. So here we go. Here is the calculator, and I'm going to show you how to type it in. There are the two. So I want everybody to take your calculator right now, if you've got one. If you've got one on your phone, use it on your phone. A graphing calculator. You're not going to be able to use scientific. And type those two in.
So X goes inside the parentheses.
Yes, make sure that the X is inside the parentheses. Because the calculator may think that you're multiplying 2,000 times 1.06 and then raising it to the X power. Remember, the calculator is not a little God. Okay? You are smarter than the calculator. Even though some of y'all don't believe that, you are. Now, look at the window that I use. I had to play with this because I didn't like the numbers that they used. So, use these windows. I think, oh gosh, I believe they've already messed up. Let me see if this is graph. Let me see. Yeah. Okay. This is the window I used. Now, the reason I used the different intervals is I was trying to get the lines to be different, and it was very hard to do. So then I went to the Excel spreadsheet and did it on the Excel spreadsheet so you can see the difference. But I'm showing you how to use the calculator because that's what you're going to use on the test. So write those values down. And you don't have to use negative 36. You can use negative 20,000 if you wanted to. I don't know why it went 20,000. You could change that to negative 1,000 if you wanted to, or negative 10. There. You could use negative 1,000. Graph. And you see that's the first one, and the second one is coming. Now, do you see where the second one takes over and goes above the first one? That tells you which method is better. The second method. All right? Because everybody knows that in the first quadrant, a higher one is better because that means more what? More money. So the second one would be your best bet in the long run. Now, how do you find the values that they want? You hit what? Table. And there's the values you need. So, I'm not going to do this part because I think y'all know how to do subtraction. But it says determine the difference. What's the difference mean? You're going to subtract. In the return. So, in year one. So, let's go up to year one. And of course, it's going to be the same because 0 exponent is 1. Zero would be 2,000. You're checking. What's anything to the 0 power? 1. What's 1 times 2,000? 2,000. So it should be 2,000 on both. 1 year. What's the difference? Okay, I'll see if I can do this in my head. Let's see. That would be $3.40. Golly, isn't it a miracle how I can use my brain? So that first one would be $3.40. 3.40. Now, y'all should be able to do the rest. So somebody do the second year. 7.10. And then y'all can do the rest. I'm not going to do any more. So look at 5 years would be there. 2676, about $30. Looks like about $30 or $20 because it's 97 against 76. That's $20. 77 to 97 is $20.
21.
So 20 what?
21.2.
Okay, let's go ahead and do it. 21.2. All right, somebody look at 10. Let's look at 10. Let's go down to 10. 35.81 and 36. Okay, so we're talking about, I don't know, $70 or what? What's the difference? $38.8 minus 35.81.7. What do we get? do this and do this. There we go. And I'm going to clear the writing. Okay, I'm waiting. 3638.8 minus 3581.7. What is it? It's not differential equations, people. All you got to do is type in your calculator. What is it?
I can't quite see on the board. What is it?
3638.8, 3581.7.
36.
I'm sorry, what? 51.1. All right, somebody do 20 years. Go down to 20. 6620.4 minus 6414.3. 206.10. Now what? 30 years. 30 is going to be 12,045 minus 11,487. 558. And 40 years. 40 years, 21,915 minus 20,571. 1,344. They probably don't like those last three because it rounded up. I'm not going to worry about that. Let's see what the answers were. Yeah, we didn't round. We rounded the last two. So you'll have to change. How do you change that? Go to Window. Go to Second. Where is it? Where is Window? I'm sorry, Table Set, and change this to 0.1 or 0.01 to the hundredths, and hit Enter. I don't know why it didn't like that. Oh, 0.01, and hit Enter, and now go to the table, and now you're gonna have. It's going to be very tedious.
Scrolling all the way down.
Okay, it didn't do the Y values. Why didn't it do the Y? I guess you have to click on it. Yeah, there you go. You have to click on it, and it might. Let's see if it does. Let me go back to table set because I don't fool with the table very much. Let's change that back to 1, and let's see if it gives you change when you click on the Y. Table. Yeah, it does. I just didn't click on it. So make sure you click on the table and make sure you click on the Y value so you can get your change, because I didn't do that. And like I say, at 40, let's go down to 40. See, there's your 91 cent. Wait a minute. Oh, you gotta subtract the 2. I'm sorry. So if you subtract the 2 there, so that'd be $21,914.91 minus $20,571.44. That should be your. Okay, does everybody see what I'm saying?
Yes.
Now, a good thing to do, look at here. I did it on the Excel spreadsheet. And to me, it's a whole lot cleaner because look at the graph it gives you. See, I like the graphing a whole lot better on the Excel spreadsheet. And as you can see, after 50 years, you're talking a major difference. Now you're talking after 50 years, you're talking about $3,000. Now, you're only talking about putting in 20,000. I mean, 10,000. What if you put in 20,000? What if you put in, let's say your grandma left you $20,000 and you wanted to save it. Now copy those two down. Let's see what happens after 50 years with $20,000. Because you're not rednecks, you don't go out and spend $20,000 as soon as you get it. You want to save some of it at least. All right? So $40,000 versus what? $36,000. I'm sorry, $368,000 versus $398,000. Is that $300,000 difference? Y'all check me. I don't know. We'll do it. Equals this minus this. So after 50 years, you got $30,000 that you made, just by putting money in the bank. Now, this is very generic. This is a very generic question, but you will see questions, you will see numbers like this at banks if you do an IRA or a 401k or whatever. You're going to see a return of at least 6%. And right now, what happened in the last 2 days at the stock market? Anybody know? Hell no. Y'all don't know because y'all don't watch anything, right? Y'all just watch what? Iron Man. That's all y'all ever watch. The last 2 days, the stock market has set high records the last 2 days. They've been setting records for the last 2 or 3 years, but the last 2 days they've been the highest it's ever been. So everybody's 401ks has gone what? Up. And everybody's IRAs have gone up. Question. Does that help on that one? Is that a good test question? Yes. Is it a test question for you to do by hand? No. A quarter by hand, the rest of it you do on the calculator. Capiche? All right, let's get back to our handy-dandy. We were at this point, I believe, correct? All right, so write those down. You've already written them down, but if you want to write them down, this is called rewriting. So if you want to, I don't know what section, did I say 6.3? I think this is 6.3, right? The second part of 6.3. The first part of 6.3, and for the 109 class, the first part of 5.3 is definition of a what? Definition of a logarithm. That's the first part of 6.3. The second part in 5.3, I think it's 5.3 and 109. The second part of 5.3 and 6.3 is rewriting. I hope I spelled that right. The second part of 6.3 and 5.3 is rewriting using these three. Now, in 6.3 and 5.3, you're rewriting. But in 6.5 and 6.6, you're going to be using rewriting, and you're going to be using definition of a logarithm to solve a logarithmic what? Equation. So, again, we're crawling before we're walking. 6.1, 6.2, 6.3 pretty much gets you crawling. And then 6.4 and 6.5, you're walking where you're solving logarithmic equations. Capiche? So, you can either expand by going left to right, or you can what? Simplify by what? Going right to left. Now write that down because you're going to be asked to do both. Okay? Question, right, complaint. Question. everybody got them written down. And you should not have to write them down. But if you want to write them down to refresh you, as far as parts. But everybody turn to those sheets that I told you that you should see it. And I want you to highlight them and put 6.3 and 109, 5.3. You need to highlight those three, and you need to say rewrite in 6.3 because I told you to write those down. Or what did I tell you to do if you didn't want to write all of them down? Go to Google and type in logarithmic properties, and you have to do that a lot of work. What do you have to do? You have to save it and then put it in a word processing document and print. So it's a lot of work, but some of y'all might want to can manage through that hard work. Okay? So what do? We look at that. So how do we rewrite the log of x, the log of 8 times x? Well, you break it up. And since these are together by a multiplication symbol,
log 10(8).
Log 8 plus what? Log of x.
Isn't that base?
Yeah, because if there's nothing there, it's assumed to be what?
9.
And I showed y'all that the other day. I think we went over that. Now you're talking, when I got the definition of a logarithm, you're talking 30% of your test. Okay? When I'm talking about rewrite, you're talking about 30% of your test. And when I get to solving equations, you're talking about 30% of your test. So if I give you 10 questions, 9 of them are going to come from 6.3, 6.4, and 6.5. And the other ones are going to be like graphing on a calculator or graphing a logarithm or whatever I showed you, an exponential and how to solve an exponential. Okay? So, what is this one going to be? Well, this is log x9 of 15 minus what?
Log base 9 of 7.
Okay, now this one, I want you to put a red star beside it. Can we solve this one? Not right now, we can't. Because you don't know the change base formula. Now, it's not equal to y, so you can't use the definition of a logarithm. You don't have anything that's equal to it. So the only thing you can do to a problem like this is rewrite it. Do you remember back in pre-algebra and algebra 1, you were given something like this? Can you solve it? No. This is called a what? And what can you only do to expressions?
Simplify.
What can you only do to rewrite logarithms or logarithm expressions? You can only simplify or expand them. You cannot solve them. The change base formula and the definition of a logarithm yields solving an equation. Write that down. The change base formula, which you're going to learn later, change base formula and definition of a logarithm is for you to solve. Rewriting is to get you to solving. Okay? This is just part of it. So what you're doing, you're simplifying. And I can go both ways. I can expand. We just expanded these. We just expanded these. Or you can simplify, which will probably be the next one. No, not yet. I'm not going to expand yet. We're still expanding, okay? Oh God, what am I going to do? Okay, here's your first rule of calculus. It's not a hard rule, but you need to write it down. Radicals and calculus don't mix. Now, if you have me for 130 or 140, and I meant to tell y'all, I need to show y'all, somebody will remind me, I'll show you when I'm teaching my 130 in this spring semester coming on, because 130, even though it's business calculus, is a good predecessor to regular calculus, but you still need to get the trig. And I'm not teaching trig. I don't know if I'm teaching trig next semester. I don't think I am. But anyway, radicals and calculus don't mix. So what do? Not do the problem, skip it, or change the radical into something else? Change the radical into something else. So the first thing you do is you change that radical into a rational exponent. Log base 5 of 8 to the what power? 1/2 power. And now we can use the power rule. Power rule says that if you have something raised to a power, you can bring that power out what? Out front. Now, of course, later on, that's going to be equal to something, and you can solve it because you can use the definition of logarithm, or you can use the change-base formula when you learn the change-base formula. But see, right now, all we did was expand it. Okay? This one right here is a property, because this is log base 10 of 1/10. And this right here, this is 2 log base 2. That's another property. And I'll just show you those, because you're really not going to... Okay, there's that one. 10 to the negative 1. And when you have log base 10 of 10 to the negative 1, okay, when you look back at your properties, when these two match, what is the answer? The exponent. Look back in your properties. When the two match, right here, and I'm going to highlight them because this is going to be a test question on a standardized test, and you're going to stare at it, and you don't need to stare at it. All you need to do is write down that negative 1. This is also a property, and I'm not going to rewrite the property. I'm just going to show it to you. Hold on a minute. Okay, there we go. Here is the property. I'm trying to do this animated so y'all... Okay? If you have 2 log of 2, 3 log of 3, when that log of 3 is in log base 2 is the same as this, the answer is the exponent. So that's 2 properties. And we went over that. There was one slide that had like 4 properties on it. And I said, make sure you memorize these properties. They're not mathematical. They're just properties. You just got to remember them. Yes, sir.
So it's x log of x of base, x to the
log base x of any number is that number.
Is y.
Yeah, and you need to, and you could also use the definition of logarithm here too, because it's equal to a y. So you have a to the y is equal to what? X, right? And now you could say y is equal to what? Log base a, what's my a?
2.
Of 2 to the what? To the, let's see, of x. And x is, let's see, y, I'm sorry, y is log base 2. I got it backwards. Let's see. It works out with the definition. I can't remember it right now. Log base, y is equal, y is log base 2 is equal to a to the, let's see, y is equal log base a of x, right? Log base a, yeah, that's right, I got it. Log base a of x. And basically, these two cancel, and you're left with 3. Okay? If you use definition of logarithm, it works. Okay? But, as you said, the rule is, if I have a base, we'll call it x, raised to the log base x of any number, then the answer is what? Any number. And that's the property it was that I gave you the other day. If you want me to, I'll tell you what. There they are. There's what I gave you. Right there. I told you there was 2 or 3 properties. There they are. That's what you should have wrote down the other day. And here's the 2 we just went over. What happens when the base and that number are the same? It's the exponent. What happens if the base and the log base is the same? It's the exponent. Of course, k cannot be negative. Okay, so with that being said, there's those. Okay, how do we rewrite this one? Well, that's the quotient rule, Hubert. That's right. So, it's also not the quotient rule. The quotient rule is right here. But what is it right here?
Power.
Power, not the power, product. You had the right thinking. So, log base A of x minus log base A of y times z. Now, how do I rewrite y times z? Log base A of x minus parentheses log base A of y times what? Plus what?
Log base
Base
A
A of z. And of course, what does that negative mean?
Subtract.
Yes, but what does it mean when it's outside parentheses? You got to distribute it. So your final answer is log base A of x minus log base A of y minus log base A of z. I'm going to put an or right here because sometimes they want you to write it all the way out and sometimes it doesn't matter. Now let's do the next one. What's the first thing I'm going to do before I even start the problem?
Change the radical.
Change the radical. Now, why are they introducing that here? Because if you try to learn it in calculus, you're going to be sunk. Okay? You're not supposed to learn that in calculus. You're supposed to already know it. And you're supposed to know it really well. So, here we go. Log of m to the second raised to the what?
1/3.
Now we got to use our power rule. Now you can use your power rule. You can bring the 1/3 out front, or you can multiply the 1/3 times the 2. I don't care. All right? I really don't care how you do it. I don't know how they're going to do it, but I would say they're going to bring it out front like this. Log base A of m to the second power. And then, of course, that comes out front. What's 2 times 1/3? 2/3. So, either way, you're going to get this answer. Let's see what they did on the first one, see if I took it. Oh, I don't agree with that. Okay, yeah, okay. They did it the same way. I thought that was a minus. I'm sorry. Okay, that's right. Okay, did they distribute the negative? Let's see, let me erase. I don't think they did. They did. See the negative? So they do want you to distribute the negative. Now, do you see how to rewrite these? They're not that difficult if you follow your directions. Is our 10-minute class over with?
Yeah.
Okay, well, write that one down, and you can do that one, and then do it for homework. I don't know how many more slides I got. So, anyway, let me cut off you should be able to do 6.1, 6.2, and 6.3. Okay?